DRCC, Dynamic Radar Cruise Control. LDA, Lane Departure Alert. BSM, Blind Spot Monitor. ICS, Intelligent Clearance Sonar, and several other systems and functions. The front recognition camera is an important input for several ADAS systems: pre-collision, dynamic radar cruise, automatic high beam, road sign assists, and versions of lane keep, lane departure, and lane trace assist rely on the front recognition camera as a primary input. Any service or repair procedures involving removing, replacing, or installing the windshield or front recognition camera will require checking the front recognition camera adjustment. The front recognition camera system also self-monitors for system performance. A misaligned front recognition camera can result in diagnostic trouble codes. Examples of these codes include C1AA9, front camera module beam axis not adjusted, C1AA8, front camera module incorrect axial gap. Always use a genuine Toyota part when replacing the windshield. The position of the camera mounting bracket, the black ceramic border, and the transmissivity of the glass are critical for proper FRC performance. An important component of the dynamic radar cruise control system, the millimeter wave radar sensor assembly, emits electrical waves in the millimeter wave band outward from the front of the vehicle. When a preceding vehicle is present, the sensor receives electrical waves reflected off the rear surface of the preceding vehicle. The system determines whether there is a preceding vehicle in the same lane and calculates the distance to it and relative vehicle speed according to the change in frequency of the received electrical waves using an electronic scan. The millimeter wave radar sensor assembly performs self-diagnosis to check if the sensor beam axis has deviated when the vehicle is being driven in a straight line. A misaligned millimeter wave radar sensor can result in diagnostic trouble codes. Examples of these include C1A11, front radar sensor incorrect axial gap, C1A14, front radar sensor beam axis not adjusted. After installing a new millimeter wave radar sensor assembly, sensor beam axis adjustment must be performed. Another radar-based system is the blind spot monitor. A pair of radar sensors are mounted on the left and right rear corners of the body structure underneath the bumper cover. These radar sensors are primary inputs for the blind spot monitor system, rear cross-traffic alert system, and rear cross-traffic braking system. Minor rear bumper damage, although it may appear to be cosmetic only, can distort the radar sensor mounting enough to require calibration. The blind spot monitor system self-monitors for system performance. A misaligned blind spot sensor can result in diagnostic trouble codes. Examples of these codes include C1AC1, master module horizontal axis misalignment, C1AC2, slave module horizontal axis misalignment. A calibration procedure may be required when a rear bumper cover is damaged, repaired, or replaced. Since blind spot monitor radar sensors are not visible from the exterior of the car, there are a couple of easy visual indicators that a car is BSM equipped. A blind spot monitor system on-off switch on the dash, or the blind spot monitor indicators in both side mirrors. These indicators light up for a few seconds when the ignition is turned on. Sonar sensors in the front and rear bumpers and possibly on the sides of the car are part of intuitive parking assist and intelligent clearance sonar systems. The intuitive parking assist system provides audible and visual warning of obstacles near the car while parking. In addition to the audible and visual warnings, intelligent clearance sonar systems can also limit engine power or apply the brakes to avoid low-speed collisions while parking. Both types of systems require calibration or initialization when either a bumper cover or a sonar sensor is replaced or repaired. Panoramic view monitor, or bird's-eye view camera systems, use inputs from multiple cameras to assemble an overhead view of the vehicle. When the panoramic view monitor system is turned on, with the switch on the dash, the system assembles the pictures from all 4 cameras to create several different views of the vehicle and nearby obstacles, including see-through view, moving view, panoramic view, and several other views are available. The panoramic view system requires specific calibration procedures when parts are replaced.